Solving right triangles. Our objective is to use trigonometric ratios to find angle measures in right triangles and to solve real-world problems. Why learn this? You can convert the percent grade of road to an angle measure by solving a right triangle. Identifying angles from trigonometric ratios. Basically, we're going to try to decide which one of these angles, angle 1 or 2, is angle A. And for this, we're using cosine. You can use sine or tangent. This example just happened to use cosine. So the cosine of angle A is 0.6. So let's try to figure out whether angle 1 or 2 is in fact angle A. Well, cosine is adjacent over hypotenuse. So for the cosine of angle 1, we have 3.6 over 6. And for the cosine of angle 2, we have 4.8 over 6. Now you can utilize your calculator to try to decide which one of these is in fact 0.6. Well, the cosine of angle 1 is 0.6 and the cosine of angle 2 ends up being 0.8. Therefore, angle 1 is angle A. Inverse trigonometric functions. You use inverse trigonometric functions when you're trying to find the measure of an angle. So, if the sine of A is x, then the sine inverse of x will in fact give you the measure of that angle, in this case the measure of angle A. Your cosine inverse of x will give you the measure of angle A, and the tan inverse of x will give you the measure of angle A. So once again, you use inverse when you are trying to find the measure of an angle. The inverse buttons on your calculator are right above the regular sine, cosine, and tangent button. To access them, simply hit the second button on the upper left-hand side and then hit your cosine, sine, or tangent, whichever one you need. So try A. The cosine inverse of 0.5 is about 60 degrees. If you've gotten 60 degrees, you're good to go. If you got a funny number, then make sure that you're not in radian mode. You want to make sure your calculator is in degree mode. Take a moment and pause the video and try B and C, and then 2A, 2B, and 2C. Now that you've had a moment to try these 5 examples, let's see how close you came. Keep in mind we're rounding to the nearest degree. So we have 27 degrees, 7 degrees, 37 degrees, 87 degrees, and 42 degrees. Let's try solving right triangles. You may need to use some of your inverse calculating to solve it. So, the first one we have here asks us to find all of our unknown measures. Well, AC is unknown, the measure of angle C, and the measure of angle A. So those are the 3 pieces of information that we're going to try to find. You are all familiar with Pythagorean theorem, and since we have 2 of the sides, we can simply use Pythagorean theorem to find the length of our hypotenuse. Lengths will be rounded to the nearest hundredth, whereas angle measures will be rounded to the nearest degree. So we can have 5 squared plus 7.5 squared, and that's going to give us our AC squared. So we have 25 plus 7.5 squared, which is 56.25, and that will give us our AC squared that we don't know yet. Okay, simplify the left-hand side of the equation, so we can combine like terms here, and we end up with 81.25 equals our AC squared. And since we want to get AC by itself, we need to take the square root of both sides. And the square root of 81.25 is about 9.01. So we can write that over here. We got 9.01. Alright, now we've got our two angle measures to go. So why don't we start with angle A? Now you can use sine, cosine, or tangent. Sine would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse. Or tangent would be opposite over adjacent. For this one, I'm just going to use tangent. So we want the tangent of angle A is going to be our opposite over adjacent. Since we're trying to find an angle measure, that's when we would use inverse. So we need the tan inverse of 5 over 7.5. And that will be about 34 degrees. So angle A is about 34 degrees. Since we have two measures of our right triangle, we can simply take 90 and subtract 34 to get our angle C. So 90 minus 34 equals 56 degrees. We have now found our three missing pieces: angle A, angle C, and the side length of AC. Take a moment and try this next one on your own. Now that you've had a moment to try this next one on your own, let's do it together. Well, we're missing one angle, and one of the legs, and our hypotenuse. So, why don't we start with angle D? Well, since we have two of our angle measures, we're just trying to find the third one in this right triangle, we can simply state that the measure of angle D is going to be 90 minus our 58, and 90 minus 58 is 32 degrees. So the measure of angle D is 32 degrees. Alright, well now we've got to use some trigonometry. Why don't we start with trying to find the side length of EF? So we can do the tangent of 58, and tangent is opposite over adjacent. So we have the opposite over our adjacent, and we want to solve for x and get x by itself. So we're going to multiply both sides by x and then divide both sides by tangent of 58. So x is 14 divided by the tangent of 58. And therefore x is about 8.75. So EF is about 8.75. Well, since we have two sides of our triangle and we're just looking for our third side, when in this case it's the hypotenuse, we can simply use Pythagorean theorem. So we have 14 squared plus 8.75 squared equals our FD squared. So we have 196 plus 8.75 squared is 76.56, and that's still our FD squared. And we can combine like terms here, our 196 and our 76.56, and that brings us to 272.56, and we're still equaling FD squared. Now we want to get FD by itself, so we can take the square root of both sides, and that leaves us with about 16.51 is about the length of FD. We can put that over here too. Alright, well we have all of our three sides and all of our three angles, so therefore all of the unknown measures have been found. Let's try using a coordinate plane. Take a moment and draw this coordinate plane as well as the triangle in your notes. Now that you've had a moment to draw this in your notes, let's look at all of our side lengths and all of our angles, since that's what it's asking us to find. Now, two of our sides are nice and easy to find because we can simply count. Like KL is 1, 2, 3, 4, and JK is 1, 2, 3, 4, 5. This one we can't quite count that way because it's going diagonally, so we can use something like Pythagorean theorem to find this out, since we know that our horizontal and vertical line meet perpendicularly. So we have 4 squared plus 5 squared equals our JL squared. So we have 16 plus 25 equals JL squared, and that gives us 41. And our last step is to take the square root of both sides, so that way we have JL all by its lonesome, and the square root of 41 is about 6.4. So we know that this is about 6.4. Alright, now we have two angles left to find. So why don't we just start with angle J? So since these two are nice and don't have decimals, why don't we use tangent? So opposite and adjacent. We're trying to find an angle measure, so that's why we're going to use the tan inverse here. And since we're using tangent, we've got to do opposite over adjacent. So 4 over 5. You can use sine and cosine. If you used sine, you would have just had sine inverse of 4 over 6.4, and you would have gotten about the same answer. And in this case, the tan inverse of 4 over 5 is about 39 degrees. So J is about 39 degrees. And once you have two of your three angles inside of a triangle, you can simply state that you have 90 minus 38 to give you the measure of angle L. And in this case, that would be 51 degrees. So the measure of angle L is 51 degrees. Let's try doing a real world application. Baldwin Street in Dunedin, New Zealand is the steepest street in the world. It has a grade of 38%. To the nearest degree, what angle does Baldwin Street make with a horizontal line? Well, let's start with drawing in our Baldwin Street here. So Baldwin Street. And now we have to kind of make ourselves a triangle, since that's what makes this a feasible question here. So we're going to assume that it meets at a 90-degree angle. And we're trying to figure out what Baldwin Street makes with the horizontal, so this is the angle we are in fact looking for. Now, we need some information to do so. So, we have 38%. Well, you can write 38% as a fraction, which would be 38 over 100. And you can think of this as rise over run. As for every 38 you go up, you've gone 100 over. So 38 and 100. Now, since you're trying to find this angle on the right-hand side here, and you're given your opposite and adjacent, you're going to use the tan inverse, since you're trying to find an angle measure. So you have the tan inverse of 38 over 100, which is about 21 degrees. Well, that ends our lesson on solving right triangles.